Good morning, students. Before this class, we will study about the rational numbers, basics of rational numbers, and properties of rational numbers. First property we will discuss about the closed property. Now next we will discuss about the commutative property. In commutative property, we will discuss about first of all addition. If a and b are two rational numbers, then the condition for commutative property for addition is a plus b will always equals to b plus a. For example, we have two rational numbers 2 by 3 and 3 by 4. The LCM of 3 and 4 is 12. On solving, what we get 8 plus 9 upon 12, we have 17 upon 12. Okay. Now next we will add 3 by 4 plus 2 by 3. Again we will get 17 upon 12. You can solve in easy way. You will get that 17 upon 12 is always equals to 17 upon 12. So we can say that when we add a plus b, or we can say b plus a, that will always be equal. Now next we have subtraction. If a and b are two rational numbers, then a minus b will not be equals to b minus a. For example, we have 2 by 3 minus 3 by 4. On solving, we get minus 1 by 2. 8 minus 9, what I get? Minus 1 and upon 12. Now here 3 by 4 minus 2 by 3, what I get? 9 minus 8, I have 1. That upon 12, 1 upon 12. So it is clear that minus 1 upon 12 will not equals to 1 upon 12. So subtraction will not satisfy in commutative property. Now third we have multiplication. Let's suppose we have two rational numbers a and b. Then the condition for multiplication is a into b will always equals to b into a. For example, 2 by 3 into 5 by 7. So 2 5 are 10 and 3 7 are 21. So 10 upon 21 I get. Now again what I will do, I will interchange of places of rational numbers. 5 by 7 into 2 by 3, but I get 10 by 21. So it is clear that b into a will always equals to a into b. Okay. Now next we have division. Let's suppose I have two rational numbers a and b. So the condition is a divided by b will not be equals to b divided by a. For example, what I have 2 by 3 divided by 5 by 7. Now what I will do, I will change the sign of divide in multiplication and I will do the reciprocal of 5 by 7. What I get? 7 upon 5. 2 7s are 14 and 3 5s are 15. Okay, so what I get? 14 upon 15. Now again what I have 5 by 7 divided by 2 by 3. Then I will change sign of divide in multiplication. But I get reply and I will do the reciprocal 2 by 3. But I get 3 by 2. So 5 3s are 15 and 7 2s are 14. So it is clear that 14 upon 15 will not be equals to 15 upon 14. Understood? Next property we have associative property. In this we will discuss the addition. If a, b and c are rational numbers, then a plus bracket b plus c bracket close is equals to bracket a plus b bracket close plus c. For example, what I have, let's suppose a equals to 1, b equals to 2 and c equals to 3. 1 plus bracket 2 plus 3. 2 plus 3 what I have? 5. So 1 plus 5 what I get? 6. And bracket 1 plus 2 bracket close plus 3. 1 plus 2 I have 3. 3 plus 3 what I get? 6. So it is clear that a plus bracket b plus c will always equals to bracket a plus b bracket close plus c. Okay, so this property will satisfy for addition. Which property? Associative property. Understood? Now next we have subtraction. If a, b and c are rational numbers, then a minus bracket b minus c will not equals to a minus b bracket close minus c. Understood? For example, what I have, let's suppose a equals to 1, b equals to 2 and c equals to 3. 1 minus bracket 2 minus 3 is equals to 2 minus 3 what I have? Minus 1. Minus minus plus. So 1 plus 1 what I get? 2. And bracket a minus b. Oh sorry. What I had? What I have? 1 minus 2. 1 minus 2 what I get? Minus 1. Minus 1 minus 3 minus 4. Understood? So it is clear that 2 will not equals to minus 4. So this property will not satisfy for subtraction. Understood? Now third we have multiplication. If a, b and c are rational numbers, then a into b into c it will always equals to a into b bracket close into c. For example, what I have 1 into bracket 2 into 3. So 2 3s are 6. 1 into 6 what I get? 6. Okay. And what I say 1 into 2. 1 into 2 what I get? 2. 2 3s are 6. That we have 6 equals to 6. So this property will satisfy for multiplication. Now for division, if a, b and c are rational numbers, then a divided bracket b divided by c will not equals to a divided by b bracket close divided by c. For example, let's suppose a equals to 1, b equals to 3 and C equals A equals to 1, B equals to 2 and C equals to 3. 1 divided by bracket 2 divided by 3. So I can write 1 upon 2 divided by 3 and 2 divided by 3 I can write 2 upon 3. On solving that, what I will take? I will take this 2 by 3 in numerator and I will do reciprocal. So 1 into 3, 3 upon 2. Here I get 3 upon 2. Now again changing the places, or we can say bracket. 1 divided by 2 bracket close divided by 3. So I can write 1 divided by 2 upon 3. So on solving 1 divided by 2, I get 1 upon 2 upon 3. On solving it, I will take 3 numerator side, what I can write? 1 upon 3. So 1 upon 2 into 1 upon 3. 1 into 1, 1, 2, 3, 6. So it is clear that 3 by 2 will not equals to 1 by 6. So this property will not satisfy for division. Understood?